Hi, everyone. We're going to go ahead and get started then. Taylor has been involved with the center for a number of years now in varying roles, so we're really appreciative of him coming back and giving this presentation today. So without further ado, I'll hand it over to Taylor now. Thank you.
All right. Hi, everyone. It's really great to be here and to be able to give this presentation. As John said, we are doing it a little different where we have a live audience here. And so there is a little bit of interaction. So if I respond to a question or something I will try to make sure I repeat any questions or anything that come up and be able to share it with everyone that's also on the webinar. But I really appreciate this opportunity to talk a little bit about technology commercialization, and especially in the solar kind of area. And first I'll ask a few apologies, just because this is a very autobiographical kind of presentation. It's a story about kind of where we went from when I was in grad school working with a technology, and then went through all the way to where we had a company and we were working towards commercialization. And so as we went through this process, I think there's a lot of things that we can pull out and be interesting, that will be interesting to look at. The other key thing for this, I would say, is that it's kind of a story of pitches. A pitch kind of in the investment community is, everyone knows about the 60-second elevator pitch that you would want to give to a potential investor that you would walk into. And so I think a good way to share this story is to plot these pitches over time and kind of look at how things have changed and what we were trying to do and what our target audiences were, and then kind of look at how that evolved as we went through the process. So with that, I guess I'll start kind of with the pitch that we first had when we developed this technology. So over the past, I'd say it's been about 8 years now, we've been developing this, which is a solar paint. And this solar paint allows us to basically build solar cells on pretty much any material imaginable. And so we decided that one thing that would be really good is that we could build it on glass, we could build it on plastic, kind of like this prototype that we had built. And this prototype that we had built, and we were looking to basically change the way that we made solar cells and make it so that we were printing them just like an everyday newspaper process, where we could just go and basically put the inks that we needed in there and run it through a process, and we really get to a place where we would think of as kind of like throwaway solar, and that this would revolutionize the PV industry. And so when we first went and started talking to people, this is kind of what we shared, is that we would want to take that. And so a little more technical details, since for those in the audience that are technical, this paint is built out of a CIGS nanocrystal ink. So basically it's an arrested precipitation reaction where we combine a lot of inorganic precursors in a 3-neck flask. We heat it up to 240 degrees C for 10 minutes, and then we cool it down quickly so that we get a fairly monodisperse solution of nanocrystals in a nice solvent. You can see that the nanocrystals themselves are about 15 to 20 nanometers in diameter, and that we could use this and we can just basically spray it on anything. And using this process, we were able to really early on get 3% efficient solar cells, which isn't tremendously high compared to all the very kind of silicon or 3.5 kind of areas, but it was something that we really could look at and say, hey, this has a lot of promise. And so using these techniques, we really did want to go out and say, okay, this is what we all picture is solar right now, is silicon solar cells that are stretched over a huge array of land, and it's capturing the sun, and we're going to go after this market and really replace it. We'll be able to print things really cheaply. Maybe they'll be a little less efficient, but we'll be able to make it at a cost-effective spot that it will really make a big impact on the industry. And at that time, I was still in graduate school. I worked with Dr. Brian Korgel, and so he found a program called the I-Core program. Now, the I-Core program is administered by NSF, and what the whole idea behind it is that it takes lab-based researchers that are doing some really interesting things and may be able to develop prototypes, and it gets them out of the lab and talking to people. And so we did this program. I filled the role of what's called an Entrepreneurial Lead, and it's basically the graduate student or the postdoc that is kind of, would be kind of the push forming the company and everything. You have support from your principal investigator, and Brian acted as the principal investigator. And then the last person of the team would be someone that has kind of a business background, and Heath Knockin, who used to work with the center also. He was able to fill that role and did a tremendous job for us. And so the idea is that in the I-Corps is you use what's called the business model canvas. And the business model canvas, its basic idea is to take that whole thing that we think about when like people are presenting companies to different investors, and they'll have like a 40-page packet, right? That would be like their business plan. And everyone talks about getting the business plan ready. And the problem is if you go and talk to an investor and he doesn't like your business plan, then you have 40 pages to rewrite and try to figure out. So the idea behind the business model canvas is that you take the key points out of that business plan and you arrange them in a way that's one page and easy to see and can quickly be iterated on. And so the very most, the kind of the key portions of the business model canvas are the value propositions and your customer segments. And so I-Corps, the idea is that you would fill out a business model canvas like this, and you would then put what your assumptions of what would happen, what your business would be, and then you go out and you talk to people, and you talk to lots of people, and as you talk to people, they tell you that your plan isn't great. And so then you go back and you fill out a new business model canvas. And as you do this, then maybe your value propositions change a little bit, or maybe the customer segment that you're trying to address changes a little bit. And then you go and you talk to some more people. And that may lead you to once again iterate on your business model canvas. And it's supposed to be a very quick process where you go around and around in this circle, and you're coming up with new theories or ideas about what your business will be, and you quickly validate them by actually going out and speaking to people and seeing if your idea has any merit. Once you do that for quite a while, then what you'll do is you'll come up with what you think is actually a business model canvas that can hold water, and then you build your 40-page full business plan, go out and build a factory or whatever may be your company may be, and put that together. And so we went through this process where we went and we talked to basically people all across the solar industry to try to get a good feel for what would be the best way to build this business and where our solar paint could go. You can see we talked to manufacturers, we talked to end users, we talked to partners, we talked to policy experts, distributors, anyone that we could find. We would basically say like, hey, here's what we think we can do with this paint. Do you think that that would have value? And the one thing that we found out really quick is that this idea to go and replace the entire solar industry, that even in our best case scenarios, that it was kind of a no-go. Like really, silicon, the price point it was at, the infrastructure that it had built around, that even if we improved our efficiency and we thought that it was reasonable that we could get to 12 to 15% and that we could then scale it up, we heard over and over that even at 12 or 15%, we still wouldn't be competitive and it wouldn't be enough to really push us to the next area. So what did we do? We said, okay, well, these silicon panels, at the time they were 60 to 80 cents per watt. I mean, they've gone down even a little bit farther than this since that point. But instead, we needed to focus on a different market, and that was the flexible solar cell market. So the flexible solar cell market is much smaller, but the actual incumbents there's much fewer of them, and they're very expensive. So we would talk to people and they would tell us that, hey, right now the military uses a lot of amorphous silicon, flexible kind of fabric and canvases and things like that, and that they were $10 a watt. And that SIG solar cells that people were putting on like RVs and other vehicles and using for any other spot that could be flexible, that really they were really expensive. They were about $7 per watt. It just was making it so that the cost was a real impediment to any solar being used for applications where you couldn't use a silicon solar cell, right? And so we focused in on these flexible areas, and we thought, okay, well, what's the lightest, least expensive thing that we could build on? And so we decided to get some nickel-coated PET. This is basically what they laminate on car windows to tint their windows. So we were using window tinting. I was using the nickel as the back contact, and as just a proof of concept, we were able to build a PV right on this basically window tint material. It was lightweight, it's flexible, you could move it around, and it had really low efficiency, but on my first or second try, we were able to get an efficiency, which I thought was enough to really put some effort behind at that point. So we took this idea and thought about it cost-wise and said, okay, well, the metric at the time that everyone was trying to reach was $1 per watt in the solar industry, and we said, well, we can't do that on glass panels, but maybe if we can even get to like 3 to 5%, we'll be able to get where we're sub-dollar per watt, and then for the right application, this will make sense, and we'll be able to move forward with the company. And so we founded a company called Lucelo Technologies. We submitted for an SBIR grant, and we received that. And so kind of the end of my graduate school experience was that NSF told me if I was going to get this money, I had to graduate, and so off I went and to do this new thing. And so Lucelo started off, and the idea we kind of grabbed onto was that we would use these flexible solar cells and basically cover anything that needed to be portable or lightweight. So we were thinking about things like a shampoo bottle, for instance, where you would have little LED lights. I'm sure everyone would be really excited to run into this in the store and have LED lights flashing at them. But we thought, okay, well, maybe all the dark parts of the bottle could be the solar cell, and then it would be able to power this, something that would advertise and draw people's attention. We thought, well, hey, if you think about a grocery store, there's labels everywhere. And so we basically, the market's enormous. You could just put this anywhere, and this is something that advertisers will love. We also thought about spots where how rigid and bulky the current solar cells are made it really, really difficult. So this is in Africa where there was a remote hospital, and so they're hauling all this equipment to basically set up a solar installation. So maybe we could make solar blankets and tarps that would be able to help in areas like this. And so, for instance, there's these tarps that like the U.S. military uses, and they're wonderful, but they're also about $10,000. And so that is just too cost prohibitive. So we wanted to kind of take all these ideas and use them and take them to everyone that we could possibly get to. The other spot we looked at was kind of like cell phone chargers, where maybe someone could have a wallet-sized, just folded up solar cell, and then when you need to charge your phone, you would just unfold it. So there's instances like this where people have very limited electricity, so you just kind of have to plug in, and so it becomes a central area. So maybe we could make something that would be personalized for each person to have. So those were the ideas we were kind of thinking about. We took a look at this and said, okay, if we do printed labels, maybe there's a $20 billion total market, and we could address like even 100 million of it. If we do off-grid solar, which is kind of those areas that the bulky stuff couldn't get to well, it's an $8 billion total market, and maybe we address 240 million of it. And then phone chargers, well, phones are enormous. Everyone has one. So it's a huge $4 billion market to provide phone chargers, and maybe we could get $750 million of that. And so you put this all together, and you have over $1 billion worth of market opportunity, and supposedly VCs, venture capitalists, will love it and come and give me a whole bunch of money so that I can keep developing. Or that was the idea that we had that. And so we went out and we started pitching this everywhere. I went and we did a whole bunch of pitch competitions, the big ones here in Texas, but even things like 1776, where they flew us out to Washington, and we were able to go pitch in front of a big audience there in Washington, D.C. And it was a lot of fun, and we got lots of good feedback. And the biggest thing that we found out was that when we said we can do all these things, that everyone asked, well, what can you do really well? And the number one question everyone asked us was, okay, what is your killer app? Like, what's the one thing that you're going to do that's going to get you into the market and get you revenue right off? So yeah, you think you have $1 billion market, but we think there's a lot of competition in that area, so what can you do better than anyone else? And we didn't have a great answer for that, honestly. And so that became our next kind of spot where we had to refine our pitch, pivot a little bit, and work on trying to understand a little bit more what we were doing. And the area that we ended up in was smart packaging. And so there's a lot of new devices that are coming out. For instance, this food sensor that is on this, it's built by a company called Thin Film. That's a Norwegian film company, but their headquarters, I believe, is now in California. And they're doing a lot of interesting things with smart sensors where you basically can take printed electronics, you can slap them on a package, they can be temperature sensors, they can do all sorts of interesting things. So they build things like this, which is a really nice little thermocouple array where it has an e-ink display, it has some memory involved, it has a thermistor, and so all these things are kind of built together, but there's one thing missing from this, and that's that all these leads go to this guy's thumb, and they would have to be hooked up to some sort of a battery component, right? Here's another example. It's it's a flexible RFID. It's printed on, it looks like just a piece of PET. So really nice little thing that you could, integrate for all the spots that we put our RFIDs for tracking and everything like that. But the one thing that's not like everything else on this is, of course, the battery. And you got this nice flexible array and everything, but then you have this battery that kind of moves backwards in where they're trying to head with all these. So our idea was, okay, let's take our thin, really flexible solar cell, and we can then laminate all these devices, and that we can be a power supply to all these. So basically, we can provide power for display RFID lighting. We can run the sensors, whether it's a thermistor or whether it's a gas sensor or a biosensor or whatever it may be. And then we can run the circuitry behind it, the memory, the logic, and everything. Basically, these all need a power source. Right now, basically little coin cell batteries are doing all these things. And so we can basically either supplement the battery or replace it. And so we went after that. We felt that like smart packaging was moving towards being a $10 billion market by 2020. And so there was a lot of opportunity for us to work in this area. So we talked to a whole bunch of people. We had a lot of partners. We had funding come in. So we had the SBIR funding, but we also had private funding that we were able to raise with companies and partners like Eastman, who provided a lot of assistance and help in lots of different ways. We talked to folks like Hallmark about looking to like integrate devices in their cards or their ornaments or whatever may be the case. And there was a lot of, we thought, really good ideas. And so we started building prototypes. This is one of our later prototypes where we had a working cell. And we found one thing that was really interesting to us is that we could build voltage really easy with this. So it was a little bit harder for us to build current, but we could give a really high voltage if we just wired things up correctly. And so you can see we had different schemes for how we would connect all the different cells and how we would print them. And we made a lot of progress, and I thought we were moving in a real good direction. The problem we ran into, though, was that just like us, a lot of these printed technologies that we were trying to power were all nascent technologies. Like, they were all really early stage also. And because everything was early stage, it made it so that when we talked to investors, they were very worried about whether all the technologies would come together. So basically, it was a large puzzle where we were one piece of the puzzle, and putting that entire picture together, not a lot of people had confidence that we would be able to get there. And so that made raising funds very difficult. The other problem that we had was competition. And we had been looking at active power supplies, but one thing that really started gaining traction as we continued on was near-field communication, NFC. And so NFC is basically where you have a small antenna, whether it's on a ticket or any of these different machines, but the power source comes from usually your phone, where you hold it close enough, you get enough RF frequency that it goes in, it powers these things up, and then they work on their own. And a lot of the companies that we had even been talking with started moving more and more where they were looking at NFC technologies. So in the end, we decided that we were a little early to market and that we needed to give things a little bit of time. So at this time, we've ramped Lucelo down so that we can kind of continue to work on the technology side, but also continue to just let the market kind of come together. And if some of those puzzle pieces really start growing, then that will be an area that we can address a lot better. At the same time, I had an opportunity where I was talking to some folks at Texas A&M University Central Texas, and they were really intrigued by a lot of these ideas. And at the same time, I had loved the startup environment, but there was some things that I had missed about academia. And one of the main things about academia that I really missed was the opportunity to kind of dig into problems a little bit deeper, especially when it's a small startup. You're just iterating and like working on prototypes and moving as quickly as you can to try to get a product to market. And so there was a lot of questions that had come up that I wanted to dig into a little bit more deeply, and there just wasn't time. We just found a solution and we moved on. But finding those solutions, sometimes I think we could have found a better long-term solution if we had had the time and energy to invest a little bit more understanding and research into the actual problem. And so I had this chance where I could go and we were able to get a grant to kind of buy some cool tools to address some of these problems. And so I've established a solar characterization lab at Texas A&M Central Texas. We work with a variety of collaborators to better understand photovoltaics, but also other semiconductor devices. So really what I did is I said, hey, what are the tools that I would have liked to have when I was in the startup community? And how can I help other startups if they have questions and they need to do some more in-depth measurements? So one of our ideas was that we would basically build a characterization lab that would be able to get some of these measurements. So kind of the centerpiece of our lab is that we have a JEOL 7610 SEM. So it's a very high resolution, really nice microscope. And we've put a whole bunch of tools on this that I think give us a very unique capability to look especially at solar cells, but also other semiconductors. So we have a cathodoluminescent system that allows us to optically look at everything in the microstructure and see how the crystal structure really is acting, how it interacts with the electron beam, how it is luminescing. We also have a PL, a photoluminescence system. So we can kind of do macro to micro analysis where we can look at things at the macro level, find areas of interest, plug them into the SEM, and then go do the same measurements in a very small and micro sense and really look at these things. We also have an EBIC that's attached to this, so we can do electrical measurements, see how the space charge region of a solar cell looks like, for instance. And we have a nice cross-sectional polisher, so we can do things across the junction and kind of see what's happening there. We have compositional measurement, and I think the big power that we have with this setup is that we can do correlative studies between all these different measurements. So we can take the optical and electrical and compositional measurements. We can really see how they're affecting each other, and hopefully that leads to a better understanding of the fabrication process and helping the folks that we're working with. So this is kind of where we're at now, where we're focusing more on working with other companies and doing a lot of collaboration and work there. So with that, that's kind of towards the end of this part of the story. I hope that it continues, and I'm confident that we'll have a lot of good success. I've had a lot of people help out all across the different universities and the different companies that I've worked with. I'd like to acknowledge Dr. Ida Tarabi, who's a postdoc currently working with me, and Dr. Porter, who's been very supportive as the VP of Research at Texas A&M Central Texas. From the Lucelo days, my partner Aaron Chokla was amazing and made all of that work possible. And then even back here to UT Austin, I guess I'm standing here, so for people on the webinar, I'm at UT Austin right now. But Dr. Brian Corgel, the group that I worked with at that, and then all the different graduate students and postdocs that I worked with all throughout the time, and then the undergrads that helped with this. With that, I would be happy to take any questions, and thank you so much for your time. Look at that, we have some actual applause. Do you have any questions?
So I'm also graduate student in physics, and I'm also doing some spectroscopy research. And one of my questions is whenever I do some researches in my project, let's say most of the phenomena I research is going to be can be realized in some lab environment, let's say. It can be only done in the very low temperature, and it can be done in the lab. But I was curious how I can connect that idea. It can be only realized in the lab to the commercialization, like you did in the when you were in the graduate school. And what was the kind of a strong motivation to connect between that?
Yeah, no, that's a great. So the question is that he does a lot of lab work at low temperatures that appear to be not very connected to commercial processes right now, and is interested in how we made the connection with our technology. I mean, so as far as motivation goes, a lot of it came from the I-Core process, and Brian contacted me and said, hey, I want you to do this, and I was a graduate student, and I'm like, hey, I guess I'm doing it. So some of it was from some external, but as I got into it, I really liked this idea about trying to think about the problem and how it would really apply in the real world. And I found that I think as academics, we're very, very good at asking these questions. Sometimes, though, we forget those real-world applications. And so I think the number one thing I would suggest is as you go to conferences and things like that, that you talk to people outside your area, because then the first thing that will force you to do is that you'll have to explain what you're doing. And as you explain it, if you can't give like a 30-second pitch that helps a layperson, like just someone that's not in your direct area, understand what you're trying to accomplish, then you might not have a good handle on how the problem would apply there. And so as you continue to do that and kind of go through this iterative process where you're talking to people and they're like, I still don't know what you're talking about, and you just get better at it, and also it will help like solidify the ideas. So that's kind of what happened to us in the I-Core process. I felt like we had a really good like 20-second pitch when we went out, hey, Solar Inc. will spray solar cells, and people would be like, well, can I put it on my house? And I'm like, well, maybe not, because now you need all these other layers, and so I realized that like first what we were presenting was probably in some ways too simplified actually, but in other ways missed some of the details of what we were trying to do. And so that changed my pitch to be like, okay, hey, I can laminate your car with this solar cell or something like that, or I can put it on a mural in your town and it will be able to light up something. And that dialogue really helped. So that would be the number one thing really, is just to talk to people outside of your area, explain what you're doing, and see how you can find a spot that it would apply. Then as you talk to general people, hopefully you'll eventually find some people that know enough about your area that you can start really quizzing them and seeing how they think that it could be applied. And I would say the biggest thing is just listen at that point. If they think that they have an idea that you haven't considered, maybe there is an application there, and it's something that you can do. So really just a lot of discussion and dialogue with a very diverse group of people. So thank you.
Great. So were there any other questions? I'm keeping an eye on the chat window, but if anyone would like to use their microphone, that's also available. Okay. Well, it doesn't sound like there are any other questions. We'll give you all just a moment if there's one that pops up. But otherwise, thanks again, Taylor, for making the drive down here to Austin and participating. And thank you for those of you who were tuning in and through the web and in person. This is an ongoing lecture series, so please keep an eye out for future updates, and maybe we'll have Taylor come back and do another one once he's figured out the next answer to his problem.
All right, thank you everyone also.
Okay, thanks everyone. Bye-bye.